Okay, I believe that we're live. Welcome, and thank you to everyone who's come along. Thank you to CSE SOC for hosting me. Hopefully today we're going to learn how to publish some Python packages. We'll talk a lot about the things that go into making a package good, things that make people trust a package, all of the little side things, because as it turns out, over the past couple of years, due to one particular tool, publishing Python packages has become reasonably trivial. So we're going to spend some time talking about like all of the other stuff that goes into publishing. So hi, I'm Nick. I apologize in advance. I'm reasonably new to this OBS thing. How's it going? I went to UQ for undergrad. I ran the Computing Society equivalent of CSE SOC up there for a couple of years, and now I work at Canva, and I'm an honours student at UNSW. And I've been trying to get as involved as I can in the society, because I know that these institutions give back far more than you put in. Awesome. So I'll go back to the slides. Let's keep going. Normally I do this talk a little more interactively. It's normally done in a room with, I don't know, 20, 30 people, and I'm asking the questions to the audience, getting people to raise their hands, getting them involved. It doesn't quite work the same way. So I will ask largely rhetorical questions. If you've got questions that come up, if you've got concerns, queries, if you want to reach out, I'm Noodle on the CSE SOC Discord. Always happy to answer questions about this, about working at Canva, about careers advice. Yeah. So here's where I would normally ask, how many of you have done something like this? And given that like the expectation here is that you've done 1531 and it's you're reasonably comfortable working in a Python environment, you've done some stuff with Flask, you know what a test is. The idea of like installing something with pip is pretty understandable at this stage. So the thing that we're going to answer today, along with like teaching you how to do it, is like how does this work? How do your packages or someone else's packages? So requests is made by a gentleman in Seattle named Kenneth Reitz, and how did he get requests up somewhere for you to pull it down with pip install? So that's what we're going to answer, and we're going to send you away hopefully with the ability to do it on your own. So part of the answer to that question is the Python packaging index. So the PyPI, which is different to PyPI, which is a whole other thing, is where all of these projects live, where all of these pip installable things live. So you can see here, there are 302,000-ish projects already up there. Millions of releases, millions of files, and about 500,000 users. It's a massive undertaking, and it's done largely by volunteers. And that's part of the phenomenal thing about open source, is that it's largely people volunteering their time. And more than that, it's a combination of that sort of give back attitude and also being able to show off your technical skills. So like PyPI is hosted on servers somewhere that, as far as I'm aware, they're still hosted on Rackspace, which is a AWS-like server provider in the United States. So they host all of these packages. We're talking about like hundreds and hundreds of, if not thousands of terabytes worth of packages. When you think about like the fact that some of these packages are like 1 or 2 gigabytes alone, so things like PyTorch would bundle an absolute crapload of largely useless but very helpful garbage. So you can go to this website, pypi.org, and search for projects. The search has gotten a lot better, but a lot of the time you're going to be dealing with packages that you've been recommended by somebody like a lecturer or a friend, or that you've seen in a tutorial. So I've been led to believe that most of you have experience with Flask. Flask is also a package on PyPI. And if you type in Flask here, you can go and find it. My exposure to this came about in, I want to say 2018. I went to PyCon, so the annual Python Australia conference. I think it was in Sydney that year, it might have been Melbourne. It's all a little bit blurry. But I saw a talk about like tools for packaging, and I thought, well, hey, I can do most of that stuff, and I'm sure I can work out the rest. So for the rest of PyCon, I didn't like really pay attention to the rest of the talks. I just sort of sat. I did the hallway track a bit, but most of the time I just sat and worked on this Slackblocks, which is a couple of Python classes that generate JSON, and when you send that JSON to the Slack API, it results in pretty pictures like this. So here, the only thing I really cared about was these little blue bars, because I wanted to be able to indicate whether a UQCS event was, or something in our calendar was either a UQCS event, something hosted by the university, or something external. So I built this library to go and do that, and over the course of the last few years, it's become quite popular. I think it was up to like 52,000 downloads. Now, you have to be careful with the download count, because a lot of that is mirrors. So people like scraping PyPI and keeping their own local version of it. But someone is using this, and people have sent pull requests, adding features or fixing things that I had initially stuffed up. So it really gets you immersed, and that's why I describe like building a Python package as the perfect side project, because this is not only something that I could build and extend my skill set with, it's also something that I could show off on a resume. So when people ask me, oh, what can I build? I say, build a Python package. And I wanted to give the tools for that. So this is the JSON that it generates, pretty like stock standard stuff, but like someone was looking for that functionality too. It wasn't just me. And you'll find that like you'll build something, and the example library that I built and finished, I want to say yesterday, though I know that there were some errors that I fixed today, were like has already been downloaded 28 times, which is crazy to think about. There are people all over the world using the software that you generate. So there are a couple of things that you need to understand in order to like interpret the code that I've written as the example. I've kept the example as small as possible, but I've tried not to pander. I've tried not to cut things out, because so this example is showing what typing looks like in Python. Now I don't know if that was expected of you when you did 1531, but here, if you've used languages other than Python, this kind of makes sense. Like having types on your arguments or your parameters or your variables, and return types on your functions is just like the done thing outside of the Python ecosystem, outside of what are called dynamically typed languages that are lean more towards like a scripting kind of environment. So someone decided, well, the creator of Python is a really big fan of this concept. So he spent a lot of time when he was working at Dropbox working on this thing called MyPy, which enforces the types, but we'll get to that. The important thing here is that these are arguments. Typed argument 1, like here, is returning is a string, so you have to give it a string or it'll get angry at you. Typed function, so this is a second argument, but Python lets you pass functions as arguments to other functions. So those functions are called callables. in typing terminology. So here we pass in a string, we pass in a function, not like the name of a function, and it returns a string. So it's going to go and it's going to run the function, it's going to return the string with that initial argument. So it's very simple, but like it's important to understand so that it doesn't seem overwhelming when you're sort of trying to interpret the code. The other thing that I want to talk about, because I think that they're really cool, is decorators. And if you've used Flask, like I believe most of you have, it's the routing in Flask and a lot of the other cool little things are built around this idea of decorators. So a decorator is this red thing up here. So in Flask you use it for routing, and this is saying if you go to route this, then return hello world. But what it is app.route is a function, and it's a function wrapping this hello world. So what this sort of translates to when you create these decorators is a function, so def hello function, that takes a callable, so the function, and that func is this one. So when you put hello function on top of hello world, this callable, it's implicit. It's one of those weird things that it just sort of happens by magic. But hello world becomes this func, and then you can do stuff. And this is the cool thing. We're going to exploit this today, but the cool thing about this is that you can define function inside a function, which is what we're doing here, and we're going to do stuff. So you can do whatever you like here. You can print, you can manipulate the function, you can add in variables, you can manipulate the arguments, you can do anything you like before and after the function. And we're going to exploit that today for the example library that we're going to publish. Another thing that I guess needs to be understood is that there are these things called ANSI escape codes, ANSI escape codes, and what they are these little, if you can see the backslash U and then like these numbers, it's the codes like they're interpreted only by your terminal. If you use these and then you print it out, it'll come out in pretty colors like this. But if you don't, if your terminal has to support it. Most terminals do, most Unix-based terminals, so that's Mac and Linux. But if your terminal doesn't support it, you'll just get this like random nonsense garbage printed out the front of what should be a nice clean print statement. So you just have to be careful when you're using these. But we're also going to use these today, just as a little aside. Now, I mentioned decorators, and I mentioned the ANSI escape codes. So what we're going to do today is take advantage of this in particular to provide a library that times Python code. Now we've done it in a reasonably small hacky way. There are ways to do this better, there are ways to do this more professionally and more accurately, but I just wanted to show an example of the kind of thing that you can pull off with these sort of, I guess, older, oblique kind of tools. So we're going to work with a Python timing library that starts out very small, and it's called small time. Now, if anyone asks, I designed this in Canva. I actually designed it in Illustrator, but I realize I'll talk a little bit more about why you should have a logo for your project and how to make it later. And it doesn't need to be this. It doesn't need to be that much effort. So this is the code. I will do most of our sort of code exploration in PyCharm. If you don't have PyCharm and you've been using, I don't know, idle or VS Code or something to write your assignments, then I highly recommend like getting integrated with a full IDE, because it's just very convenient. And when you get to industry, like they might let you get away with the, like, I don't know, working in Vim or whatever, but it's for most people the benefits of a full IDE are enough that like it's just kind of the assumed thing. It certainly is at Canva. So this is the code. We've got one class. The class takes a single argument that's optional. So this is more of that typing stuff. If we don't give it a name, then we're going to generate something called a UUID, which is just a random assortment of codes. And these codes have been designed specifically not to collide with one another in the generation. So like you shouldn't, if you generate 1 billion of these, very few of those should be the same. I think this particular algorithm might be like 100 in 1 billion. So we're also setting a value of stored time to 0, and we have 2 functions that make up the rest of this class. You can see here a little hack to do with the typing. Because we're like self-referencing small timer, we can't just put small timer as the type there, the return type. We have to do it in quotes, and it'll fix it later. Here we're using some colors.color. So that's the thing that's going to insert those ANSI escape codes with the pretty colors. So it's going to make the foreground, so the text color, white, and the background red. And we're going to store the time. So this is just the most accurate clock that the time module provides, returning a value in nanoseconds. Now, one way that you could extend this to make this more human-friendly is to translate that nanoseconds into something that human beings might actually want to read, because nanoseconds get quite large. It's just like accuracy is, I guess, the primary thing when people are testing things. Like if you go on Stack Overflow, you'll often see where people are disagreeing about where you can see people are disagreeing about like the way to do things or what might be faster. Like they'll do some quick timing. That's the idea for this library. It's like if you want to test whether like creating a list from the list function or just like the square brackets is faster. Spoiler, it's the last one, but you could use this library. So we're storing the start nanoseconds, we're storing the stop nanoseconds when we do stop. We throw an error if you try and stop it while it's already stopped. And we return the delta. So we print the delta, we tell them how much it elapsed, and we're also, so that they can keep track of like which start and stop things are related to one another, we also put the name in there using F strings, which I hope you've already covered. All right, so that's the code as it stands. This is the format. All we have is this timer.py. We also have a decorator. So I mentioned that we were going to use decorators for this. We are going to time a whole function. So this gets a little bit messy. You'll see like the nesting here is kind of insane. The reason that that's required is so that we can pass in the arguments into time. So if you want to give it like the timer a name, you have to wrap it in another function in order to pass that in. The guess dynamics of this aren't hugely important. There are really good tutorials for this on the internet, but once that's set up, so you can see here, we're passing in the function, we've got an argument to the name, we're either going to name it or we're going to give it the name of the function, which is like a little bit of hacky Python meta programming. We're going to start the timer, we're going to run the function with whatever arguments came in, we're going to stop it, and we're going to, we're relying purely on the side effects, so the printing out here. So then we'd use it like this. We put the little decorator on there, and that's largely the functionality. Now, I mentioned that there was this thing that had made this whole process a lot easier, and that thing is Poetry, which is a package management system for Python that sort of brings it in line and steals a lot of good ideas from the JavaScript ecosystem. So if you've ever worked with JavaScript, you'd be familiar with like npm modules and whatever, package.lock or package.json. So the lock files and configuration and all that, like Python has been lagging in that area for a really long time, and Poetry is lovely because it just brings together so many things that were disparate tools, and it does it really well. The only problem that it has is that it's a little bit slow with development. It's maintained by, as far as I can tell, like a single guy in France, and I think he has difficulty delegating. But yeah. So these are the things that it does. So you've got environment management. If you run Poetry shell, it'll spawn a virtual environment for you in a temporary, in a cache directory in your operating system, and it'll be able to find that again should you like leave the shell and come back. It'll just use the same one. Very handy. It can do dependency management. The commands are a lot like Yarn, so rather than like pip install, you do Poetry add or Poetry remove, which takes a little bit of getting used to, but it kind of makes sense. Excuse me. Poetry also provides this run keyword, so you can do Poetry run and then give it any shell command or Python command, and it will sort out your Python path. And it also does publishing for you, which is what we care about, and it does it in a very, very simple way. So this is what we're going to do first. We're going to take that code in PyCharm, and we're going to integrate Poetry. So we're going to go and do that, and we're also going to add a license, and I'll talk a little bit more about licenses. But I picked a BSD3 license, which is just one that I know the rules of and don't mind too much. I recommend this website for going and finding a license that suits you. I think the default for a lot of projects on GitHub is MIT. If you have like a business audience in mind, they much prefer Apache 2, but yeah, you'll work it out. Let's go and have a look at PyCharm, and we'll do this magic. We will. I guess I should point out I may skip ahead if I screw something up in order to not like slow down this talk while I figure it out. I've set checkpoints on branches, so and I may skip ahead just because like writing into configuration and checking that it's like correctly spelt or whatever is not what you're here for. So I may skip ahead. So when you see me typing GCO, it's just git checkout, and I'm just switching to another branch with more progress. So let's do Poetry magic. Now you have to install Poetry in your like system-wide operating system, like in your system-wide Python version. I've already done that. You can do it with pip install Poetry, or I think brew install Poetry will also work on Mac. But for now, let's just do Poetry init. So it's pretty smart. It's going to walk you through like a generation thing. So it'll ask you your package name, it'll ask you the version that you want. I normally start pretty low. I'll talk more about semantic versioning later, but Like low numbers mean low responsibility in terms of what people are expecting of the code in terms of quality and reliability and maintenance, like your readiness to go and fix things when they find out that they're broken. So we start low. You time things in Python. You can change all this later. That's me. That's a old email address, and then BSD3 clause. There's a list of these on the Poetry website. Sure, that'll do. I think we can be a little bit more. I know which value you put in here, but you can do it whatever you like. There's no real expectation anymore to support Python 2, but you can if you want to. Now it's asking, would you like to define your main dependencies interactively? We'll say yes for now. Well, I'll do one that way, and I'll do, so let's say ANSI colors, because that's what we're relying on for that. And 0 is what we want. And we'll just take the latest one. And I'll add short UID on the command line. Now dev dependencies, like we'll want things like Pytest. Oh, I've screwed that up, but that's all right. Let's do that. Confirm generation. Now we will have some magic file. Well, we'll have at least one magic file. So it's generated, this is a TOML file, which is a very interesting setup. But you can see here that it's added ANSI colors at the most recent version. Now we can just do Poetry, add, what was the other one? Short UID. Okay, and we also want Poetry, add, so we'll get to it later, but we want to add a dev dependency of Pytest. So the users of this don't need Pytest to use the timer, right? So that's like, we add it to development dependency. Then if they choose to, I think by default Poetry installs everything, but they can choose to not install dev dependencies if they want to. So you can see that's popped up here, and we've got short UID. So we've really got everything we need. I won't demo this right now because it's reasonably self-explanatory, and it's cooler to show it as a command line tool later on. So we've done that, and you can also just pretend, actually, I'll just throw away what we've done. Huh? Oh, interesting. Okay. All right, so we're on the master branch, and I will just show you what the license looks like if you haven't seen one before. It's reasonably boring, like legalese boilerplate. You can copy it in, or when you create your Git repo, you can just choose one and it'll generate it for you. All right, let's keep going. I realize that I talk a lot, and so here's one thing that we are going to add. So an init.py is a file that you can use. Like it denotes that a package is like a directory is a module in Python. So that means that you can like do dots, like relative references or absolute references in Python imports through it. But you can also use it here, and when you're creating libraries, it's particularly cool because you can make shorthand versions of things. So here, like, we don't really need them to write in small timer, so we can do import small timer as timer. And then because we've put these things in the init.py alongside our code, it means that they don't need to go from small timer dot timer import small timer. They can just do from small timer import timer. It surfaces the parts of your API that you want to what you actually want the users to use and see, which is very handy. So if I go and switches back, this switching of things is not nearly as elegant as I would have liked, but that's all right. I need a third monitor screen. Okay, so yes, you can see it there, and we're just from this timer file we're importing the things that are relevant, the things that we want our users to be able to just go from small time import blah. And you might have seen or come across issues around that in your own explorations with code. So let's keep going. I have to remember to switch that back. All right, the next step in our journey to providing a package that looks impressive to employers and that people in the open source community are comfortable using is providing some tests. So I understand that you guys, if you've done 1531, have exposure to some Pytest and some fixtures. So this should all be reasonably straightforward. So I'll just go to step 2 and we will have a look at our tests. So you can see if you go into your PyCharm settings, and God, I hope you can see the pop-up windows. We want integrated tools. There we go. You can select Pytest as your default, and then it will pick up on it. So the thing about Pytest is that the files need to start with test, and the tests themselves need to start with test. The classes, so here I've got a couple of different types of tests. I've got some reused variables, and I've got this type, this fixture type, because I wanted to be consistent with my typing, and that's what. So capsys, capsys is a fixture provided by Pytest. It's sort of inserted, and it means that you can capture the standard out and standard error of your programs. So all I've done here is run the program, capture the standard out and standard error. We're only really interested in the standard out here, and then assert that things are where they should be. And then I've done it sort of a more complicated example, so testing that you can nest them and that they come back in the right order, and that just that they're in the right place, and then testing the decorator as well. You can be a lot more exhaustive. I think this got to about 74% test coverage, but as I'll get into later, test coverage is not the best of metrics. So that's our tests. We can run those using the fail ally. Oh no, okay. So I guess the thing you might not have seen, the thing that at least that I've seen is quite common in industry, is that these smoke tests. If you are really in a hurry and you're not just kidding yourself that you're too busy to write tests, a lot of people will write smoke tests to basically just import all of the code and check that it doesn't crash. So yeah, but I mean, people are generally, I get a little bit disappointed when I see that in production code at various workplaces. So those are tests. Again, you can get more sophisticated. This is a very simple library, so very simple tests are fine, largely. So let's keep going. Slides, there we go. So yeah, that's what changed. We just added that single test file. You can break them up if you want to. That's our example test. Now, we're going to add something called black. Now, black is a auto styler. So the auto styling is seems to be where things are headed. Like the sort of like styling your own code, or like having your own distinctive style means absolutely nothing to an employer who has a distinct process. Like at Canva, there's a script, and you just run the script, and if the script says it's okay, then like the style's fine. If it doesn't, then it'll fix it, and you can just commit it, and that's it. Like there's no like personal preference stuff. Black very much falls along those lines. It's an opinionated type of formatter, and I mean, for the most part, that's good. Like if you don't care, then that's fine. If you do care, you can go and format, like you can go and change the settings. But like the idea that you'd be like manually adding new lines at the end of your files to fix stuff is sort of very much past its use by date. So let's go and do that. This is probably the shortest step in today's adventure, because all we have to do is add a dev dependency. So we go to our terminal, we go poetry, add -d black. So we've got black here now, and if we do black dot, so style everything, okay, so it's gone and it's reformatted one file and left two files unchanged. So that's all it does. Hopefully we'll do that sort of automatically, and you can do that on the Git side if you want to with Git hooks, but I don't cover that today. So the next step, we'll git stash and back to our slides, is a README. Now, I tend to go a little bit overboard with the README. I mean, you can just do the absolute bare minimum, but in my experience, like a README, a good README says that like someone cares about this project, and if someone cares about the project, people are more likely to use it. So let's I mean, there are a few components, there are a few things that you need to have, so let's go and do that. It's just Markdown. It's described as a superset of HTML, so you can also just write HTML. GitHub may not like all of the HTML you want to put in there, particularly if it's malicious, but you work it out. So let's do step 3. Oh, no, we've stepped over step 3. README. So it doesn't look very impressive when it's not rendered. Markdown is amongst the ugliest of languages, but you can see here I've got some HTML in there. This is just the logo. Again, talk more about that in a sec. And then we've got these. I'll come back to those. But these are like the more important things. So you want to describe what it is. You want to like tell people what it's for, preferably in like a very short sentence, so that they can decide just by looking at that whether it's what they need or not, because that's typically the mindset that people come to random GitHub projects with. And we'll also reuse this for the description that goes along with our published package on PyPI. But yeah, we'll get to that. So where we've told them what it is, we tell them like what the requirements are. You can link to the pyproject.toml so they can go and have a look at them. But I think the most important thing is telling them which Python it supports, how to install it. I tend to advocate for poetry here, because I don't know. It was like poetry had been around for years by the time I came across it, and I just wish I had had it that whole time. How to use it. So here, how to use it inline, which we've already seen, how to use it as a decorator, and something that we're going to get to as a later step, how to use this as a command line script as well. So, and normally I mention something about the license, though, if they're particularly interested, they can go and do that. They can go and look at the license for themselves. Most people won't care, but for those people using it in a commercial application, it's more important because they have to know their rights and their obligations. People don't like a lot of the viral licenses like GPL because they require too much of a commercial company. They require the open sourcing of code that it's used in or whatever. So just be mindful in choosing it and being upfront about what you've chosen and why. So let's keep going. We've done that. Now I have to spruik at least once because there is a chance that my employer or somebody who works there will see this at some point. Now, when I gave this talk to UQCS, I made a different library called HousePaint, which used ANSI codes to color the whole contents of a function. And I made this logo in Canva in about 8 minutes. If you happen to have design skills, then go ahead and use whatever you want. Canva is really good and really easy for what it is, and you don't have to the only reason that I know how to use Illustrator and made the logo for this project was my mum is a graphic designer. I grew up with Illustrator on all the computers and just sort of assumed to learn. So I recommend Canva for peace of mind and less time spent. The other thing, because you can put that logo in your README, you can put it on your documentation, and it just it builds a brand around your project. And the projects that are the most successful, like Flask or Requests, that have millions of people downloading them every day, have had logos sort of from the very early days. So Flask's logo is instantly recognizable. Request's logo, a weird geometric thing that Kenneth Reach drew once, is very recognizable. So if you create something, you can use it to build that brand and make it recognizable too. The other thing that is really cool about the fact that your READMEs are basically HTML documents is that you can include dynamic stuff in them. So you can include these things called shields. And the shields do very cool things, like tell you whether the build is passing, or tell you which versions of Python it supports, or what the code coverage is, or what the formatter is, or even what the license is. All of these things can be communicated through shields, which I will show you in the sort of finished product. But all of these shields, you can get from shields.io, or for code coverage, it might be from the code coverage provider like CodeCov or Coveralls. But we'll get to those too. Let's move on. Okay. So one more step. I mentioned that we put in types, and I mentioned this thing called MyPy that Guido van Rossum is a big fan of. If you want to verify that your code is correct, type checking comes under a static analysis kind of code, and you can do that as part of your process. So you can install MyPy, and I'll just switch over. Okay. 05, which now there are the observant among you will notice that there are 2 step 5s. I kind of lost count as I was going because I was in a bit of a hurry, but let's go and see. So we can do poetry, add. Again, this is one of those things that is a dev dependency. It's not something that people need to run the program. It's only something that you care about. And you can see, like, because I've skipped ahead, it's already installed. But what we can do is run MyPy. Now, bear with me one moment. There is a slight deviation to this command. So poetry, run MyPy, small time, dash, ignore, missing, thanks, imports. If the libraries that you're relying on, like some of the ones that we are, don't have typing, so if ANSI Colors doesn't have typing, or if small UUID doesn't have typing, interesting. This is one of those times that I'm very glad that I... No. So this is, okay, so it's telling me that the environment's already activated, poetry install. Ah, okay. For some reason MyPy, oh, we added it, but it wasn't installed, all right. So static analysis is a time-consuming process because it's got to look at everything and often double back on itself. But it'll come and tell you. There shouldn't be any typing issues in this, I hope. There we go, success. So yeah, that's just something that we can add in to be sure. Now, if I was to go into the timer and, like, I don't know, change one of the types, say I like change this to string, and then reran the type checking. So it's telling us that the return type here is incompatible. So those are like things that people who write compiled languages take for granted that they're going to be told by the compiler. Python, because it's dynamic, it's like, oh, we don't know. So this sort of ad hoc solution to checking for those things is really handy when you like when you're dealing with big programs and you don't really want to keep all of it in your head. So let's go back. I knew I should have set up keyboard shortcuts. Cool. So we've done that. We've typed. I've explained types already. It's kind of redundant. Now we're going to do the second step 5, which is adding command line scripts to the program. So basically, when you ship your program, like if you've worked with Flask, when you do Flask run, that Flask has got to be something somewhere. It's got to be on the path. It's got to be created or installed by Flask when you install it. So we're going to show you, or I'm going to show you how to add that to your own program. So basically, like what ends up happening is that, like, you create a Python program, point poetry at it, and it wraps it in a shell script, and that shell script becomes what you run. So here, I apologize for all the code, but this is our pyproject.toml. You should be used to that sort of toml notation now. we're going to add this bit, this tool.poetry.scripts. We're going to give it a name, so that's going to be what we call on the command line, so st. I don't know, I was feeling lazy, and I feel like other Linux developers do too. And then there's the command line, the script that goes into running this. So here, I don't know, I've got a custom error class because, I don't know, I wanted something better than what argparse spits out. But here we set up argument parsing. So argparse is a built-in library. You don't have to install anything, it just comes with Python. It's very handy. There are other libraries that do the same thing if you're making command line tools like Click, which uses decorators to accomplish the same thing. And as much as I love decorators, I really don't love Click. So that's a thing. We've added some arguments, and the arguments are going to be whether you want to give it an optional name or not, the command, so the command line program that you want to run, any arguments to that program. We're taking 0 or more, this little nargs thing, and passing those args, checking that the command was there, telling them how to use it if they messed up, starting the timer, calling the command that they sent, and stopping the timer. So that's like, it's very, very simple. This is only ever meant to be like a demonstration library, but let's go and check that out. So we're back in PyCharm. We will GCO to step 6. Oh, no. It's the second step 5. CLI tools. Cool. So we have added this CLI folder. We've explained what's going on in the code. We've got in our pyproject.toml, and we've got that st thing down the bottom there. So let's check this out. We may have to poetry install again, just so that it registers and creates that little command line script. And now we should, if this works, right, cool. So like I was keen to show you the actual output of the program, so you can see the white foreground text, the red background. It's not very clear in this particular terminal's color palette, but it's running echo high, and it took this many nanoseconds, and it's got the label there. So that was always the goal. We've now created a thing. So once we publish this, people will be able to pip install small time, and then run, provided that it should be on the path at that point, and they should be able to run st, and then any program they like. So we can do like, I don't know, sleep 5, and it'll sleep in the middle, and then it'll tell us that it went for a lot more nanoseconds. So that was the goal. We've now got a script, and Poetry makes that incredibly easy. It's just very nice. We'll keep going. All right. I wish I could see questions as I go, but I promise I will follow up in the YouTube comments after. So the next step is, like, this is all a lot. Like we've just described a whole bunch of steps, right? And we're not quite done with the steps. So we want to automate that. And I think, like, demonstrating that you not only can use like CI or like understand what it is, but also the fact that you can set it up is quite beneficial when you're, like, I don't know, selling yourself to an employer, and being able to say in a resume, like, set up a full CI pipeline, have a Python project that's, or a PyPI project that's downloaded X many times, like all of this can go into you as a marketable quantity. So yeah, we're going to add some GitHub actions. Now, GitHub actions look like this. You go to github.com/marketplace, and there are a bunch of things, and basically all they are is like scripts that do things, and they're generally well described, and they have like usage instructions, and all it boils down to, you can see over here in this file that we're going to like create and use, is like action/checkout. So actions is GitHub's like first-party provided ones. So checkout, so that just checks out the repository. Then you've got another actions here, again provided by GitHub, that sets up Python with Python version blah. One of the extensions for this kind of thing is to do matrix builds. So building across multiple, like running all of the testing across multiple versions of Python is a little bit tricky to do, but very worthwhile. We're installing Poetry, installing small time and any dependencies. Ooh, and a typo. And type checking and running the tests. So that's like all of the steps that we've described up until now effectively are being done automatically by this test workflow. So let's go and see. The other thing, it's less relevant to this workflow, but when you work with GitHub Actions, sometimes they need secret values. So like things from code coverage providers or tokens from PyPI in order to actually do the work or authenticate themselves. You can't put those things in your code. Please don't put those things in your code. But you can put them in as secret and then reference them with a special notation that I'll show you shortly. But let's go and run this stuff. So we're back in PyCharm. We are going to skip to step 6. Now, like, I could write all these things out while we were here and explain them, but I feel like it doesn't really add any value for you to watch me type. So I'll just explain instead, and then we can watch the really fun thing, which is watching the CI tick over. So we've set up a thing with a name test, and this is like, I don't know, this syntax, this is YAML again, but this syntax is like, I don't know, seems tortured to me to like need to nest all of these things. But here we're going on push or on pull request. So if someone makes a pull request to your repo, or when you push to branch master, or they make a pull request to branch master, it's going to automatically run these tests against, like all of these tests against the code that's relevant. It's running on Ubuntu, so the Linux distribution, and we're checking out, we're setting up, we've got Python, we've got Poetry, we're installing. Again, Poetry makes this much nicer than the traditional Python, like pip install -r requirements.txt. Yeah, so then we've got the type checking and the tests. So when we commit that code to the repo and push it. Oh god, now I've got to. Yeah, here we go. Spoiled things, but ignore that. You can see here there's this little red X. Ignore the red X. So let's rerun it. So just imagine we've committed that YAML file for the first time. It's creating, like, it's setting up these tests. It may take a while because this is all free. Like GitHub can make you wait or whatever you want. you can see it's doing all of these things for us. And I mean, you may have to, there may be a bit of back and forth with you trying things out, with you needing to change parameters. So you may get a few failed test runs. Unfortunately, there's no real way to test these locally, but you can edit in the browser. It makes the dev loop a little bit smaller. Yeah. So this is just some additional steps. So yeah, and it's done, and we've got the green tick. So we know that we're okay, and then we can move on to the most exciting part of this, the thing that I've been, I guess, promising since this talk was first advertised. Ooh. And actually publish some packages. So we're gonna like, you can see here that we're adding more workflows to do this automatically, but I will show you how pathetically easy it is to do initially, like we just with poetry. It's just that like doing it from the browser is safer and nicer, and you don't have to do anything manually or keep any keys handy. So let's switch back to PyCharm and GTO step 7, publish. So there are two versions of PyPI. There is a test PyPI and a regular PyPI, the production one, and they're like identical services. You just push to one or push to the other. It's kind of annoying because you have to set up separate credentials for each of them. But once you've got those set, it's reasonably limited effort. The thing is that when you push them, when you create them, you have to make sure that the version doesn't clash. If the version already exists up in PyPI, then it's going to spit it back at you and say, no, we couldn't push this thing. Now, if we run poetry build, it's going to create some stuff. So you can see it's built an SDist and a wheel, and I will talk about those in just a second. And stuck them in dist build. Where's build? They're around here somewhere. They're not like human readable files really. They're like gzipped and wheeled things. They're, I don't know, PyPI will understand them and unpack them and do what it needs to do. So all we need to do is poetry publish. Now this assumes, I should actually, before we do that, let's go back to our browser. And we'll go into sort of what PyPI looks like behind the scenes. Let me log out. So this is PyPI. You've seen the screen cap. You log in or register, just like any other website. And you'll see the projects that you have. So Blackbox is the one that I mentioned earlier. Housemate was that other like example library, and this is small time. So I've already pushed a couple of times today just to test that things weren't going to go horribly wrong in the live demo. I'm just going to copy the password for that website. You'll see why in a moment. Let's do PyCharm. So once you've got a username and password for that, you can do poetry publish. And again, make sure that your version is not clashing, and it'll be a username. So Nick Lambourne. Paste that password in there, and now we can go and have a look. So we refresh. We can see last released 20 seconds ago. Sounds about right. Oh, I didn't switch that over, did I? Apologies. There. Released half a minute ago. We can go in and view that. And you can see the README is here. That won't happen by default. I'll show you why in a second. But it's live. You've published something. Now, if we're good internet citizens, what we would do would be to publish to test PyPI first. I'm not, like, the people that know me well know that I'm not a particularly patient person. And I've played this game before, but the situation is exactly the same. With test PyPI, you just change. Here we do poetry. I have to remember how to do it. Poetry publish -r test PyPI. God, I hope that works. Just have to grab that. Password, because again they're different. Yep, and it's done the same thing. Now this is how, like, people target. You can run private versions of PyPI, and a lot of people do. There's a service called Artifactory that I believe Atlassian used or still uses to, like, host custom Python versions. We don't really in Canva, because we have the mono repo and we can just access shared code. We don't need to package it up really. One thing I will mention while we're here are these things. Now these didn't come, well, first let's talk about the README. README is not a default argument when you set up poetry, but once you do set up poetry and you have a README, you can just do this and it will populate the README on PyPI with your GitHub README, which is very handy and pretty. The other thing is these classifiers. Now you can, like, I think it's pypi.org/classifiers. You can see lists of these, and what these are like shorthand for telling people things about your package. So it doesn't look very short here, but when we go back to PyPI, I don't want to test PyPI, I want real PyPI. So you can see here these classifiers down the bottom. So development status is going to set the expectation of, like, how well maintained is this code, how, like, what's the licensing. It's just like, this is how you communicate with developers searching for particular things, like particular factors. And you can also, this is a little bit niche, but there are, like, let's go and have a look at them all. There are a bunch of them. So there's this list of classifiers, and they do everything from, like, CUDA support and Django version and licensing, language that it's written in, non-Python languages that like the code is written in, which environment it's for, like the categories. Like it's sort of endless, and there's, like, a diminishing return on, like, finding more of them. But I don't know, I picked a couple as an example. They're just something that you include. It's just the norm. And when you there are certain ones that are picked up by those shields that I mentioned. So when we go back up here, you can see that like it's from those classifiers, it's dynamically determined that the versions of Python that are supported. All right, I'll keep going. Now we've yep. Now, I promised I would explain the different packaging and what an SDIS was. So the Python file is what we started out with at the beginning of this talk, just the standalone Python modules, generally with the .init thing in them. An SDIS is for pure Python, so like Python packages where there's no other languages, no other assets in there. So Python can be extended. You can include Rust code or C++ code or C or Fortran code in your distribution if you want to, but not in an SDIS. SDIS is for Python only. A wheel, on the other hand, which is like the primary sort of the go-to format for the current era, is you can include all of those things. You can add extra junk in it. The PyTorch like the PyTorch wheel includes something like 1.1 gigabytes worth of CUDA drivers, so like C++ compiled code for every version since the dawn of man. So I mean, for the most part, like just Poetry builds both by default, so you can just roll with that, publish both, and it really won't come up unless you want to get fancy. Semantic versioning. So this is the versioning that I've used here, and the versioning that's like largely accepted in industry. Obviously, you get people who have their own thing. You'll often see like people using the year in the major version column, like JetBrains does with their IDEs. But typically, like if you're changing a major version, you're introducing breaking changes. So like Python 2 to Python 3 broke a lot of things. Minor changes are like introducing new features but not necessarily breaking anything. Patches fix like security flaws, and then you've got alpha and beta releases for like additional clarity if you want. Now, again, this is like, even though that was only 2 commands, we can do better. We can automate this, and we're going to do the same thing that we did for all the testing, but with publishing as well. So we'll jump back. And at this point, nope, we're still in number 7. Okay. So this one is a lot simpler. There's only one step. Oh, sorry, we've got the checkout, but we've only got one other step, and that's poetry publish. So somebody has gone and done the thing. Like they've written however many, like a couple of lines of code to wrap up the poetry behavior that builds it and publishes it, and all you have to provide is the token. So the token is an alternative to your username and password. You can't use username and password in CI. I mean, you could, but like you'd be committing them into Git version history, which is almost impossible to undo and just a bad idea. So let's go and have a look at PyPI and see if we can find ourselves a token. Account settings. Yeah, so API tokens. So I've got a few here. Thankfully they don't show you the value of them. You give the token a name, so YOLO, because you guys are going to see this. I'll just delete it. And you can choose the project. You have to. I've already uploaded it by manually in order to get project-specific scope. But you get a token like this, and that's what we're going to take and shove in. I'm going to delete it, but oh god. There we go. We go back to our repository, we go into settings, we go into secrets, and we go into PyPI token, and you go in and stick that in there, and save, and then in the script we reference it like this. So it's this weird and wonderful notation, secrets.pypi token. So that's just going to find it. Like it knows to reach out for that. It knows where to find it. And when we push that, it's not going to do anything by default because of this. We have set this up very deliberately. Releasing a new version is not something that you typically want to be done automatically, at least not at the scale of an individual project. Unless you're doing like a nightly release or something. So what we've got here is on push tags and then this pattern. So we're going to basically say only when this pattern is created in the name of a tag, and I'll show you that in a second, are we gonna push it up. So let's go back to our browser. And we're going to go in over here to releases. So we're going to be there. We are going to, it's easy to get your, I won't change the view over, but just I'm just changing the version and pushing that because it's easy to get the version out of sync. So we're going to draft a new release. We're going to set a tag, and we've got to start it with v0.0.7. Create new tag. We'll do the same thing here. Now just imagine I've updated the TOML file to do the same thing. And we will publish a release. So what that's going to do is go into actions. We can see this job has been triggered. Oh god. I have a bad habit of putting a full stop as my commit messages because at Canva we use squash and merge as the merge strategy, and it doesn't matter what your commit messages were, they will just get murdered. But you can see it's going and building, it's getting all the stuff that it needs, it's installing the things. You'll see a few names in there that we haven't gotten to yet, but that's just because there are more. One more step, or two more steps to go. Thank you to anybody who's stuck this out. I know it's a long one. So yeah, we've published to PyPI, and if we go over to our projects, we should see last released half a minute ago. That looks promising. Make a typo. Oh, I think this is a caching issue. Yeah, you can see here that the PyPI version is recognized. If we go, come on. There we go. So you can see then we can go and I suppose let's do the thing. Let's confirm that we've done the thing. So yep, install small time. Requirement already satisfied. So it's gone and it's looked for it and it said, oh well, we've already got that because we built it locally. But now, like theoretically, any of you can go and install small time should you wish to for whatever reason. So we've done the publish thing. What is our next step? Yep, we'll talk about versions. We're going to, our second last step is going to be adding code coverage. Now I'm very skeptical of code coverage, but what we do here is we're going to use a service provider called CodeCov, and we're going to set up a couple of config files. Now, like the importance, like I don't know, you can pretty much just verbatim copy these if you want to. There are like examples on the websites. There are a few things that I've changed, but it's incredibly straightforward. All right, GCO step 8. So we've added a couple of dependencies. The Pytest cov will basically extends Pytest to generate coverage reports, and its dependencies of like coverage and stuff, like it's all sorted, and the coverage RC, we're just telling it not to run in certain areas, yes to run in some places, and relative files is the thing that CodeCov requires. And then this was just because I didn't like seeing like a red build on the code coverage shield. You can change the target, like what your coverage target is. There's a very like limited benefit to coverage above sort of 70-80%. I know some people strive for 100, but it's just like the value isn't there, at least for people that value their time. So once that's in place, rather than like generating the coverage locally, we add it straight into our test automation. So we're going to run the test. What we've changed here is we've added this -cov, so that's where it's going to put it. It's going to be in XML format. Again, we don't care. This is straight out of the vendor website for setup. And then there is another action that uploads it to CodeCov, and it's maintained by CodeCov, which is nice. Like you want a first-party action if you can get it, because it's one of those situations where you don't know what people are doing in their code unless you go to the effort of digging through it yourself. I mean, they could theoretically be sending it off somewhere. Anyway. So once code coverage is set up, it'll just run as part of your tests, this one, and you need to get another secret, so you can get your repository upload token. You can steal that if you want to. I'm not really fast at this point. And you'll get pretty graphs. So it'll tell you that, well, my test coverage has been declining as I've added things over the course of the last few days. And like that's generally what you want to watch out for. The trends are more important than the actual numbers, but it will also tell you like what you're like, but on a file by file basis, what you need to do, and where you need to put your effort. Again, coverage is a dodgy metric to start with. So that's that. And the last thing, we've finally reached the last step. We've done the publishing thing. Let's say hypothetically your package is taken off, it's expanded in scope, it's getting a little bit complicated, and a quick usage guide in your README isn't cutting it anymore for documentation. So again, this is one of those situations where I'd ask the assembled audience, has anybody seen a page that looks vaguely like this? This is like the read the docs format, and this particular one is for an open source project that I work on in a research capacity, but it's just an example in this case. We're going to use a tool called Sphinx. Sphinx is reasonably friendly, but definitely can be tricky or have weird edge cases. So the two most important, Sphinx is another one of these things like poetry where it'll auto-generate a bunch of crap for you and populate it. You just choose the default options for the most part. And then there are two files that matter effectively until you add more. So the first one is this index.rst, which stands for restructured text. It's the predecessor to Markdown. It's not quite as HTML supersetty, but it was the default in Python for a really long time. Your other option is using mkdocs to do the same thing in Markdown. Honestly, I'm just it's kind of like Stockholm syndrome. I'm used to this by now. The other thing is the conf.py. So again, there's a lot of crap. This sys.path thing is commented out by default. There's a lot of just nonsense. Well, not nonsense, but largely useless comments that fill up the rest of this file. But it's just Python. And you just set a bunch of settings to change things. So the ones that we care about are the release. You want to keep that in line with your release. I always forget, particularly that other project I showed you when we released docs, they're always out of sync. But you could theoretically reach up into the pyproject.toml and just pull it out of there dynamically, which would be much more clever. We're going to use Autodoc. The other things are just it's that's documentation coverage, which is similar to your code test coverage, and Napoleon just allows for more varieties of comments of doc strings. So let's go and look at those. Is there anything else? I mean, most of this is straight out of the box. The only thing I changed was the Sphinx read the docs theme because it's prettier than the Alabaster that it comes with by default. That's another Python package that you install. You set your logo. I changed the header background color because I'm anal. Let's go and have a look at that in PyCharm. So from here, you do something like Sphinx. Quick start. Oops. 09. So Sphinx is another Python package. You just add it dash poetry add as the same as the theme. The only other thing that you need to do that's not self-explanatory that took me a while is if you want read the docs to automatically generate it and render your stuff correctly, you just need to add this, and you also do config in a read the docs format. And this thing in particular, this extra requirements docs, it makes very little sense to me, but the internet said it, so and it works. So there's that. So you config. Read the docs is the other people that host it for free, and they have their own setup. So once you've got that, the other thing that like happens in the index.restructured text, all of this is default except for this auto module small time.timer. So because this is small, like we can keep it all in the same restructured text file in the index, and I'll show you what that looks like rendered in a moment. So browser, we're on the home stretch. So projects. You import a project. It's kind of similar to CodeCov. Oh god. There's no search functionality, as I found out. So if you're part of an organization, then there are so many till you finally get to mine, and then you, I don't know. Let's say this one. You get to a screen like this. Default branch, you can choose advanced options. It does most of this for you. That works. Choose a programming language, tags, and then you click finish, and it'll probably go and like, I don't know, it might fail. You might need to like adjust something, or the reason that I added that extra line to the toml and to the read the docs config was because it wasn't rendering the README for some reason, but those combined, those things fixed it. But then once it's all done and you've finally build, you can check the builds. It's just like CI, and you go in here. If it's failing, then you can go and see why. It's just sort of raw text, and then you can go and read the docs. So this is it. I mean, obviously there's not much here. It's a very small library. It doesn't even need documentation from my perspective. But again, being able to say that you did this or that you can do this is valuable. Being able to set up documentation like this is something that people have to do in their jobs, and like employers and recruiters sort of appreciate that. If we want to see, so you can see this is the output of the autodoc stuff. So it's gone and it's found all the modules. It's included the types, which is nice. It didn't used to do that by default. And yeah, it's generated some other stuff, but really it's very empty. If you want to see a more like fleshed out example, here's that other one that I showed. So you can see like there are like getting started and like different guides, and then like the API documentation is the last thing. Oh, and it's broken. Well, that's not very good, is it? But I guess the more important thing is that you can combine, like if you have markdown guides or whatever, you can, like, most of these are markdown based. They're not restructured text, which is a little bit of a pain to work with, but you can just add in a plugin and it'll automatically convert it for you. So that's the kind of thing that you can have with your docs, and again, like, keep that branding going. Now, if you want to take this, like, go ahead, like, the very, very open source friendly. If you want to take the structure, if you want to, like, wholesale copy paste stuff, then, like, go ahead. I do not mind at all. If you want to keep building on it, few of the things that I've listed along the way, matrix testing, so testing across different operating systems, different versions of Python, or both. You can get like, I don't know, dozens of tests happening at a time. Very cool, including binaries, so using something like PyInstaller to generate an actual executable file for each platform. The downside to that is you need each platform, so you have to use a Windows computer to generate a Windows binary. It's a bit of a pain in the ass. Python, so C extensions to Python. If you've got like something that needs high performance, or you just want to do it for laughs, you can use Python extensions. So like includes C code that runs and like hands back and forth between your Python code and your C code, and it's just incredibly fast. Python is slow, like everyone acknowledges that, and there's not really much we can do about it with C Python as it is. But yeah, Python is an option. There's also like oxidized Python, so doing the same thing with Rust. You can also, as I mentioned, use Git hooks for like auto formatting when you commit. Is another thing that like is reasonably straightforward to do, but again, this talk was already pretty long. Hopefully somebody's got some value out of it though, and that's it. Thank you for coming along. Thank you for bearing with me through whatever it was, like an hour 35. And yeah, if you've got any questions, hit me up on Discord. I will open the YouTube comments now and see if anybody has asked anything. Okay, it doesn't look like there are any questions. I guess I'll sign off. Yeah, thanks all. And thank you to CSE SOC and the workshops team for having me.